Chair for this session is Srikanth Chandrasekaran sir, the Senior Director IEEE. Sir, I request you to please come and chair this session. And the moderator for this session is V. Manjunath sir, who is Regional Standards Manager, South Asian Sub-African countries for ULSC. I welcome you, sir. Speakers for the session are Ms. Lonneke Driessen, who is Director, Open Charge Alliance. I welcome you, ma'am. Then we have with us thank you all for clapping. Even if I forget you, please do introduce. When I introduce, you should please welcome all of the guests who have come from long way to attend these sessions. Then we have with us Ms. Neha Agarwal, who is Scientist D and Joint Director of BIS. Welcome you, Neha. Then we have with us Mr. Amarjeet Kumar, who is Founder and CEO, Comminent Private Limited. Welcome you, sir. We have with us Mr. Ravindra Desai from IEEE. Welcome, sir. We have with us Mr. Remi Demerle, who's Alliance Partnership and Marketing Director from LoRA Ecosystem. I'm sorry if I've pronounced something I'll like. And then we have with us Mr. Dinesh Sharma, who's Director SESEI. Welcome, sir. So I now pass on the mic to Mr. Manjunath to take this forward. Thank you.
Good morning. Am I audible? Yeah, thank you very much. And it's a great honor and pleasure to be here. This is my second workshop which I am attending. And it's always a great pleasure to see all of you here. Though I was telling Amarjeet, Ravindra, all of them that we get to meet once in a year. It's only here, though we are neighbors, right, Amarjeet? So, however, I think this is the diversity that we have, and it's an opportunity that it brings all of us to talk about something which is really evolving. As all of you would be knowing, India has embarked on this PM Har Ghar Muft Bijli Yojana, which is basically creating those 6 million rooftop solar system which gets integrated onto the grid. And all of us know how challenging it's going to be. Not only one on the grid integration, it's also going to be on the cyber security, the points that we may have the injection of the cyber security threats gets into million points, right? It's not just one. So how do we really look at that is going to be an important factor. And what a great opportunity to have the standards development organizations coming together, which so clearly tells what the WTO principle talks about, the coherence. Look at the way we are sitting together, IEEE, ULSC, BIS, IEC, all of us are sitting on this common platform to discuss and see what are the standards that we really need to evolve so that this ecosystem can be safer. So while I talk about the next, what the session's going to talk about, let me quickly introduce UL. UL Standards and Engagement is a non-profit standards development organization accredited by ANSI and SEC and also recognized by DGN to develop the national standards. We work very closely with BIS. It's providing our inputs in developing the standards. Congratulations to the entire team in working relentlessly. I think it took almost 2.5 years for us to come to a conclusion that 1547 should be adopted with the India differences, while 50 hertz and 60 hertz was a major thing. But however, there were multiple things which has been discussed, the islanding, the frequency, the voltages, all of these have been addressed very well. I think we need to really look at how do we integrate that and implement it in the grid. That's going to be the work which has been already taken up. I'm glad that Reji sir reached out to us in terms of testing these inverters, which is already in progress. And as we said, in 3 weeks down the line, we would have some results to talk about. And I think we need to really look at the grid profiling, particularly with reference to Indian context, because the grid profiling that has been considered is IEEE. USA. However, with reference to Indian grid, we need to do it. So these are all the challenges. However, even the cyber, IoT, all are the things which are going to discuss. So considering that, it is an important thing for us to bring what are the various things that you are really anticipating, the technologies that are coming in this area, and let us prepare ourselves to develop the standards which are relevant in the global context, rather than we developing, like someone develop the standard, then we keep on adding few more things onto it. So with that, I think it's a great opportunity for me to moderate such a wonderful session. And Srikanth being the chair, I would request Srikanth to give his opening remarks, and then we'll ask the speakers to come.
I don't think I need much opening remarks. I already gave my opening remarks, but it's an honor to chair this particular session. I think what is unique about this session is it just doesn't have standards bodies, but it has laboratories and implementers who are going to discuss key aspects. So I look forward to the deliberations, and I want to see how we can work with all the different stakeholders in India to really make sure that we are able to implement this successfully and address any gaps that we find in a meaningful and effective way as we move forward. So with that, I will hand it over back to Manjunath, and we can get the show on the road.
Thank you, Srikanth. I think we have 120 minutes. Thanks to everyone that you accepted not to have a break. So 120 minutes and six speakers, 20 minutes each. However, I think we need to have time for question and answer. So may I request all the speakers to limit their presentation to maybe 15 minutes, so that we have 5 minutes for question and answer. So first presenter here is Ms. Lonneke, who is the director of Open Charge Alliance. May I request, she is going to talk about the emerging smart energy technologies and standardization landscape in global perspective. I think she is going to talk more on the communication and the IoT related things. Over to you, Ms. Lonneke.
Just one quick intervention. You will see two versions of my spelling here. The one that you see on the screen is the correct one. The one you see on this one is the wrong one. Okay.
Thank you. While my presentation is being set up, I'd like to first of all thank you for offering the opportunity to speak here today. I have been coming to the India Smart Utility Week for a number of years, and it's always a pleasure to see the familiar faces, but also learn about the progress that is being made. My name is Lonneke Driessen, and I'm the director of the Open Charge Alliance. And as you may hear from my accent, I'm Dutch. I come from the Netherlands. I have prepared a few slides for you to update you on OCA and OCPP, and I'll start at the beginning because maybe some of you are not quite familiar with the Open Charge Alliance, so I will give a brief introduction. Yes. So Open Charge Alliance is an industry alliance, so in that sense we are not like IEEE or IEC, which are standard setting organizations, but we are an industry alliance founded in 2014 as a non-profit organization in the Netherlands, with the goal to help the EV charging industry accelerate. So that's our goal. We want to help the industry move forward. We manage one standard, only one, as opposed to the IEEE and IEC ecosystems of 100 or thousands of standards. We govern one standard called OCPP, which stands for Open Charge Point Protocol, which is a protocol for communicating with charging stations. What's important to note is that OCPP is freely available, so it's open source. There's no licenses included, there's no intellectual property included, and everybody and anybody is free to use it to their advantage. The only thing that is copyright protected is the name OCPP, so it's trademarked. So we have been developing OCPP together with the industry over the past 15 years actually, and every new version of OCPP we release includes field experience because our industry is developing quickly and learning quickly, but also new features that come to market. So OCPP started in 2009, 15 years ago, which is quite a long time in our industry. And the most widely known version of OCPP is OCPP 1.6, which was published in 2015, so already a decade ago. And this version of OCPP covers basic functionality you need for charging, authorization of a charging session, transactions. It does cover smart charging and reservations. It is a basic version of the OCPP protocol, and if these use cases are what you need, this is a perfect version for you. And the Open Charge Alliance is still supporting this version from 10 years ago with certification services, testing tools, plugfests. So if you use OCPP 1.6, you're all set, and you can continue using OCPP 1.6. However, if you want to unlock new features and new functionalities, you may want to look at the more recent versions of OCPP, OCPP 2.0.1, and the recently published OCPP 2.1. And in this slide, you can see that every 5 years we increase the functionality, and particularly the most recent one, OCPP 2.1, covers the bidirectional charging and also the adherence to DER regulation. And it was mentioned a couple of times before, the IEEE 1547 standard. That's a standard that we've benefited from hugely. So we've read it carefully, and we've made sure that this OCPP 2.1 version covers all the requirements in IEEE 1547. Should utilities want to allow aggregators to control inverters? So with battery charging in electric vehicles, of course, you also have an AC and a DC converter. With big DC fast charging stations, the AC to DC converter is in the charging station. So there the utility would want to control the inverter in the charging station. When you look at AC charging, the converter is in the vehicle itself. So one option could be that utilities control the converter in the vehicles, or you can require a CPO, a charge point operator, to control the inverters for you. And the standards that you can use for controlling vehicles are of course, the CHAdeMO standard, which originated in Japan, or the ISO 15118 standard, which is an ISO standard. So there you have several options to choose from. What you can also see is that as of the OCPP 2.0.1 version, the protocol is also published by IEC. So it's also an IEC standard. So the development is not complete yet, and our industry is still continuing to develop. So this year we are focusing on a light task group where we look at including OCPP in resource-constrained devices. So many big DC fast charger have Linux systems where you can put a lot of code on, and you can be quite heavy on your coding. But if you look at more affordable chargers, more lightweight chargers, they have embedded systems, not a lot of RAM or ROM or flash memory. So there you actually need to focus on coding actually quite compactly. So you can have a light implementation, but still unlock all the values that the more advanced versions of the protocol offer. We are looking at improving the networking in OCPP when you want to have load control with local controllers. And it was also mentioned this morning, security. We have a special security task group, which is very important, I think, in any industry, but also in EV charging, because it connects the electricity grid with transportation. So those are both critical industries. OCPP has security included. OCPP 2.0 and onward have security embedded incumbently. But it's always good to double check if all the security requirements that we describe are sufficient, and if we need to do more on that front. So that's also a very important task group. And lastly, we have a new commissioning task group. When you install a charging station in the field, you have to activate it. And at the moment, that's all depending on which brand of charging station you're using. And for installers in the field and even customers, that might be a little bit complicated. So we're trying to see if we can make this easier and more standardized. So it becomes much easier for lay people to commission charging stations. I mentioned before OCPP 2.0.1 is now published as an IEC standard. The number is 63584, so it's a little bit hard to remember. It's not a very obvious number, but it is an IEC standard. And all the future versions of OCPP will again be offered to IEC for fast-track adoption. We have a liaison with IEC, so liaison experts are free to join the Open Charge Alliance and join in the discussions. So that's great. And all the draft documentation will also be shared with any interested IEC working groups so they can provide feedback along the way. This is a graph of the member companies. So Open Charge Alliance is a member organization, but you don't have to be a member. You can always use it. But if you'd like, you can become a member. You see that most of our members come from Korea, which is the most prominent region where OCPP is being used. We have 6 members from India, and we're really proud of our 6 members from India. If you look at the split in the bottom of the slide, the participation between Asia and Europe is about 50-50. But I explained that OCPP is free to download. You can use it regardless. And if you look at the number of downloads, and these are the numbers of downloads of OCPP over the past year, you actually see that India is quite prominent in downloads. So the United States downloads OCPP most. It makes sense because OCPP is also required in the United States, or at least was until the Trump administration. Is currently a bit unsure what the Trump administration is planning to do with EVs. But India is right up there. And I think the most obvious explanation, of course, is that one of your major export products, or how do you say it, what you have in India, is your IT industry. So everywhere across the globe, people use Indian companies to develop their software for them. That's one reason. So you can see that there is a lot of knowledge in India about OCPP, and this is the already existing services industry that you already have. And it would be great if that could translate also into your manufacturing industry, and that actually Indian companies will also start benefiting from all the knowledge in EV charging, and also start producing charging stations and exporting them to all the regions that are using OCPP, because that's what you can see in this graph. It's hard to read, but there are so many countries. OCPP is being downloaded to 132 countries. So a lot of countries are interested in e-mobility, and they could very well benefit from the industry and the knowledge base that you have here in India. India is, of course, focusing on bidirectional charging and DC fast charging and bus and truck charging, but there are also 2 other very interesting developments that are not only in India, but are also mainly in India. And that's why we are, in addition to the DC fast charging and the bidirectional charging, we are also focusing on, as I mentioned, the 2.0 Lite, which is the lightweight version that you can also use in more affordable chargers that you could use to charge 2-wheelers and 3-wheelers. The indication is that it sort of could be coded under 200 kilobytes, so it would actually fit on an embedded system. And the last use case is also something not only in India, but definitely prominent in India, is the battery swapping. So in 2.1 we also added use cases for battery swapping, should you want to go down that business model. Also discussed about the harmonization of different standards. So since OCPP is used in many regions, we make it a point to look at different standards that are used in different regions. I mentioned previously the IEEE 1547. I think that's quite prominent. If you look at the communication protocols from the grid to charge point operators, or aggregators as you could call them, we see, of course, OpenADR, also IEEE 2030.5, but also a lot of utilities are working with IEC 61850. So what we've done in the grid, the DER support messages in OCPP, we have mapped them onto all those different standards. And we need translation tables to say, okay, if a utility wants to communicate using 61850, this is how you can translate it into a single OCPP message, which is the same message that you can talk to using 2030.5. And that's the way we address the use of different standards, aligning standards in other regions. The same goes for the downstream communication to the vehicle. You have CHAdeMO, of course, which is used in Japan. Also the ISO 15118, which I already mentioned, but also the IS 17017, which is a particular Indian standard for AC-DC combo charging. So this was a brief introduction. I hope that it has informed you a little bit more about OCA and OCPP. And if you're not into electric vehicles yet, found it very easy to spot them when you drive around Delhi. So anything with a green license plate is electric. So, and I was very encouraged to see electric buses, electric tuk-tuks, and electric vehicles from Tata. So I think the electrification here in India is definitely happening. So I would encourage you, if you drive around, to watch for the green license plates and see the transformation happening here in India. Thank you.
Thank you, Lonneke. If there are any questions, I think we can take those questions. Can someone pass on the mic here? Sir.
Yeah, okay. Thank you. Thank you. Thank you very much, Lonneke. Very good presentation. It gives really in a nutshell the essence of what is on the table, what can be used, and but also it's very impressive to see the history of all of this. And I personally commend the success of OCPP, which is a monument, and I'm sure that the success comes a lot from your personal capabilities that I've seen at work for a long time. I have a question about, I have a question here on this presentation, but I guess it would apply to a lot of alliances, which is, as you've shown, you see, all the alliances are moving very carefully from one version to the next one, and this is really sound, and there is no other way to move forward to success. But the issue for decision makers who have to invest in infrastructure is to wonder if a given version is the right version to start investing, because no one wants stranded assets. So the question is, could you share with us what is the thinking or the strategy of your alliance to actually be able to always move forward to a next version, making sure that this is not creating damage for the one who have invested in the previous version?
Does it work? Yeah. So thank you for this question. It's very important. So there's a little bit of a giveaway in this slide, because here you see the color of OCPP 1.6 as orange and the colors of OCPP 2.01 and 2.1 as purple. And what that means is that the OCPP 1.6 version, which was an iteration of 1.5, 1.2 and 1.0, and actually from the start of OCPP, wasn't sufficient for us to move forward. So we decided to make a lot of changes in OCPP 2.0.1, which also resulted in breaking. So 2.01 and 1.6 are not backwards compatible, and it takes a lot of effort to update your systems from 1.6 to 2.01, and that has been holding many companies back. They have invested a lot in the, version 1.6, and now they are faced with another big investment. So we've taken that on board, and we've particularly learned from the CHAdeMO Association, where they have focused on backwards compatibility from the beginning. So that's why we said, okay, we should do that. So we should also make sure that OCPP 2.1 and future versions of OCPP are backwards compatible with 2.0.1. What that takes is discipline in the technology working groups, because it's of course logical that 5 years later you can think of a lot of improvements, but if they break backwards compatibility and they're really not that crucial, what we've done over the past year is constantly ask ourselves, is this worth breaking over? And we've managed to be disciplined enough so that the 2.1 version is backwards compatible with 2.01. That means that once you have set up a 2.01 system, it's very easy for you to update. So that's a answer to your question. So the backwards compatibility is so important, and we should not repeat. It was not a mistake, because we did it for good reasons, but backwards compatibility, we think at this moment of the industry, is of the utmost importance.
Thank you very much. I think it gives a lot of certainty about future investments. Yeah. Thank you.
Thank you. Any more questions from anyone? Well, Richard, the questions that you asked, I think if we have to really expand a little, I think even in batteries, I just have to give the analogy, because the advanced chemistries are coming in. how do we really have those batteries being addressed, being safer when we're using it. So the standards are not being prescriptive. They are really looking at how do we have these standards which are agnostic to any particular technology but addresses the safety, which goes as a philosophy, and I think it goes even when it comes to the charging EVSEs, where we can look at safety as a parameter, giving room for innovation to happen in the manufacturing and the designers. I think that's the philosophy which I think all of us are working in the standardization, which can be a good philosophy for us to consider.
I think it makes us touching a key reason why sometimes issuing an international standards can actually take a huge amount of time. Of course, the alliance, what I like in the alliances is that they are building consensus like SDOs, but the number of members and the categories of stakeholder represented in the members is a bit smaller than with an SDO, which means that this gives the strength to move forward quicker. But this is, you see, this key question of backward compatibility is really sensitive because some people might not want to cast in concrete some clauses too early because they may know that there is a lot of work going on with new possible options in the future. So they hate closing the door too early to issue something cast in concrete. And this is really the tricky part. As you said, it's not a mistake. No, it's not a mistake. You have to move at some point. You have to move. Otherwise, nothing happened. So this is really, maybe, to me, this might be one of the most important points we've been discussing here today in this workshop, because this is really where decisions are very tricky. Should we wait more or enlarge possibilities before issuing a standard, or should we just close the door? But when we close the door, which major options are we eliminating for the future? When we close the door, when you close the door of 1.6, of course, I'm sure it was possible at that time, if I remember well, to foresee that there are options considered in OCPP2 that were possible at that time. It's not that all of a sudden after 1.6, there was a completely new innovation and that was unknown, and then, of course, we could not know. No, it was known, and I don't want to enter into the technical details. I remember, I think we had discussions on that. But this is the only way to move forward. This is very tricky, and we need to keep this a live question for all the SDO activities when we're developing in a working group a document. Where is the dotted line in which we may say, okay, let's close the door, but not completely, but make room for possible evolutions, even if it's not sure for today, but let's leave open, even though it costs a bit because it will require more work to actually even issue that standard. I thank you very much, Lonneke, for this very, very concrete example. But this is the way to move forward, and I applaud, you see, what you've been doing, and I'm eager to see what will be the next version.
Thank you very much, Richard.
Oh, yeah.
No, go ahead. Nothing, no worry. You can respond.
Yeah, so one other thing that I'd like to point out, and this is very down to earth, is what we see is that a lot of the companies that are participating have a lot of work to do, so they are understaffed and they have a lot of other priorities. So what they can do is provide feedback and suggestions and field experience, but there's also a big part in standardization that's actual the legwork, the technical editor work, writing stuff down, condensing proposals, giving options. And that legwork is something that you need the brightest people for, because they can listen and synthesize what everybody is saying, but they also need to be paid, and who is funding them? And that is something, at least at the Open Charge Alliance, we have some funding through participation fees, and the majority of the fees we spend on technical editors who are neutral, very smart, and they do the legwork. And that is something that I would suggest to IEEE and IEC. So can you find a model where you can have people to do the legwork? Yeah.
So,
Yeah. Makes a note. Yeah.
yeah, so I think just to respond to this question first, I think that's what we call it pre-standardization work. And that is a very, very painstaking and very laborious and very methodical work. People do not have patience today in industry. So when you do not have patience, you will never have a overarching understanding where we stand today, where we are going tomorrow and day after tomorrow. We need to look into right from the past to the deep into the future to have a proper structured roadmap of standardization in any domain which is backward compatible. But then again, having said that, talking about backward compatibility is easier than done. Okay, now, no, it is. But then, with my experience in design, I have seen now, I think we need to define the contours that these are the kind of things where we need a consistent, this would be like some things which we cannot change with time, or when design in the industry during new manufacturing in the next 10 years, can be standardized on this aspect. Which are those aspects which can be like firmware upgrade, much easier. You can have a different versions. Okay, anybody can upgrade their product. But hardware changes, and even the protocols like file layer is a very difficult thing to change from time to time because of whatever reason. Okay, but then the other layers, software layers can be changed to improve performance, to improve power consumption, whatever they may be. I think so this is where when we start developing any new set of standard for any particular domain, we need to be very cautious to demarcate these, which are the things which will face problem in the long term and which will not face problem. Give extra weightage to things where we need durability, we need long shelf life of the standard, and then only develop the overarching thing. I think that would be very important. Yes, it takes a little time, and I think pre-standardization study is part of the ecosystem, I think, but we do not collaborate very, very well. SDOs are focused on, they have their own limitations. I work across SDOs. Okay, every SDO has a limitation, they have their own strengths. So we need to work together. I think this is the kind of platform where we can come together and discuss, help each other, come up with a mature standard which are future-proof.
Thank you, Kishore sir. Is there any further question? I think we are good. Thank you very much. You concluded well in advance as per the time. Thank you. And if there are no further questions. Now may I request Ms. Neha Agarwal, who is the Joint Director, Bureau of Indian Standards, to talk about the standards, the role of National Standardization Body and the standard that has been developed. Huge kudos to the ETD 44 team, 46 and 46 team in developing this adoption of this standard. I think it took almost 2 years for them to come to a conclusion. Congratulations, ma'am, on the great work. Once again, I would also like to take this opportunity where IEEE 1547, where UL was one of the key member which participated in development of the standard and also complemented with the test judgment criteria which has been defined through UL 1741, the supplement B, which talks about how you really assess and what is the judgment criteria for a smart inverter. So with that, let me have...
Thank you. Thank you for introducing me. A very good morning to all of you. I'm Neha Agarwal. I'm Scientist D and Joint Director in Bureau of Indian Standards. And I'm also Member Secretary of the TD46 Sectional Committee, which is working in the area of standardization for grid integration of renewable. So quickly moving to my presentation. So I think most of the content in my presentation has already been covered in the inaugural address, by most of you. So, but still I'll go through the presentation and will share the important information. So, so since morning we are talking about the standards, like what is we have the people from IEC, IEEE and UL and BIS, which are all are working in the field of standardization and developing standards. So, what is a standards? So, these are the different definitions that I have taken from different documents available. So, if we will summarize this, so we will say that standard is a document which is established by a consensus and which will provide the guidelines, the set of rules that one may follow to have the best results and the good products and outputs. Now, coming to the types of standards. So, most of the organization, and if I'll talk about the BIS, which is the National Standards Body of India. So, type of standards are covered in the the basic standards, which are like the terminology standard, which covers the terms and definitions of the related product or services. There may be the testing standard, which prescribes the test and procedures. There may be service standard, product standard, process standard and interface standard. So, these are the basic types of standard that are available and that are being developed. So, by looking at the screen, we can see that standards are everywhere, like from the beginning of the starting of our day, when we wake up and till we sleep, we see there are so many product services that we utilize during the day, and for that standards are available. So, like in the picture you can see each and every product has its own standard, and standard defines their requirements, their testing and everything. So, but we generally do not notice that standards are behind each and every product and services. Why? Because unless and until we feel that there is a problem with this product or with this service or with this system. So, once we feel that there is some problem, then we see that how it was being made, then we go to the bottom of the product or the service, then we feel that if there is some standard behind the product, that it must have some quality and the problem could not have been arised. So, lack of standard can have their own consequences, like from mere frustration to loss of life and property. So, thereby standards are very important, and they in our day-to-day life they play a very important role to ensure the quality, to ensure the lifespan of any product or service. So, like I mentioned, one of the important aspect, like why standards are important. So, these are the first and very most important, that standards control the variety and they ensure the interchangeability and the compatibility. For example, if I'll tell you one example, standards define the sizes of the shirts. For example, if you can see, if there is no standard size of the medium or the large, then you will the consumer may feel very frustrating by trying that different sizes of the shirts at each and every store. So, if standards are there, then you will see that same size for the medium, same size for the large. So, thereby it will ensure the quality and the services. Another important aspect is that they defines the health and safety, and standards are also defining the environment conditions, that like the recyclability, reusability and disposal of any electronic products or any electrical products or related. So, thereby standards are also ensuring that the systems and products are safer to the environment. Then it also helps to the trade. When we follow the standard, then it product will ensure the bare minimum quality, and it will help manufacturer to trade your product at the border and cross the border. And it will definitely, the last but not the least, to protect the consumer interest. So, standards are thereby play a very crucial role. Now, coming to the Bureau of Indian Standards. So, Bureau of Indian Standards is the national standards body of India, and we started our journey in 1947 as an Indian standard institution and with the name of ISI, and the certification scheme was launched in 1952. Thereby we became the statutory status by the when the BIS Act came up in 1986, and it gave us the statutory status on 1st April 1987. After that, in 2016, this BIS Act got revised and gave BIS more power, and it makes the BIS as the national standards body of India. So the core activities of BIS include the first and very most important is the formulation of Indian standards in each and every field. And another important activity is the conformity assessment, in which BIS is marking the ISI, BIS is working in the ISI marking of the products. Then self-declaration of conformity is there for the registration scheme and hallmarking system certification. We are having the labs also, we are having 8 labs and more than 300 labs have also been recognized by BIS for testing of the product as per the Indian standards. And we are also providing the training in our National Institute of Training for Standardization, which is situated in Noida. So these are the core activities of BIS. So BIS is also founding member of ISO and IEC. So we, as far as possible, we try to harmonize our standards with IEC and ISO to facilitate the trade between the, to facilitate the trade between the borders. So most of the Indian standards are being harmonized with ISO and IEC. And coming to the technical divisions in BIS, so in BIS standards are being developed by the technical divisions. So we have like 15 technical divisions in BIS in each and every field or in each and every discipline of the engineering and beyond to that, like in civil engineering, chemical, and if we talk about the water resources service sectors. So these are the different technical divisions there in BIS. And standards in the field of electrotechnical area or the electrical engineering are being developed by the electrotechnical department. In electrotechnical department, we are having 46 sectional committees which covers the different areas of the electrical engineering. For example, transformer, wiring accessories, power capacitors, we have rotating machinery, grid integration of renewable, electric mobility, energy storage systems. So each and every field of electrical engineering is being covered by the 46 sectional committees under electrotechnical department of BIS. Now in each and every technical committees we are having stakeholders from different areas. So we are having the government people from the government bodies. We are having people from the regulators on board, and we are having industries, labs, R&D institutes, consumers and academia. So, so we try to balance the committee composition by bringing together all the experts from the concerned areas, so that the standards can be, standard is consensus based, it is neutralized and it is not biased. So all of them come together and they sit together and they brainstorm, and that's how standards are being developed. Now what are the stages of and how standards are being developed in BIS? So the first and very most important stage is the new work item proposal stage, which is a proposal stage. So there we receive any proposal from anybody, like from covering from the industry to the academia, on which standard needs to be developed. So that proposal then being evaluated in the concerned sectional committee from which it belongs, and then a working draft is being prepared by all the members who are there in the sectional committee. And then when the working draft is gets ready, then it is being circulated to amongst all the committee members as a P draft. And after that we receive the comments, and then comments again they are being resolved and incorporated into the draft, and that's how wide circulation draft is being prepared. That wide circulation draft is then being uploaded on the BIS website. There it is accessible to each and everyone who are not there in the BIS, and there that's how you can access these drafts from the BIS website to offer your comments. You can review the drafts from there, and after that, when we receive the comments at the WC stage, that's how these comments, again those comments are being resolved in the sectional committee, and that's how the final document is being developed, and then it's published and gets the status of the Indian standards. So before publishing any Indian standard, it goes to the various stages of developing the consensus, and that's how these standards are being developed. Now coming to the main topic of the today's for which we have gathered, which is grid integration of renewable. So I have mentioned few challenges that we faced when we integrate the distributed energy resources into the grid. So I am sure there may be more challenges, but I mentioned few. The most important challenge is the variability and intermittency. So as we all know that solar and wind are very variable and they depends on the weather conditions. So it affects the stability of the grid. So for that we need a solution, and the solution is the energy storage technology. So we need to develop the best energy storage technology to store the energy when it is in abundance and to use in the peak hours. So for that we have a dedicated sectional committee that we will that I will cover in my later slide. Another and important challenge is the transmission and storage of renewable energy. Since the generation of renewable energy is located in the very offshore and the very remote location, and from there to transfer that energy to the location where it is needed, it is a bit challenging. And in between we may lose most of the or the substantial amount of the energy, and for that we need grid modernization efforts, including the development of smart grids and improved transmission infrastructure in order to transmission that generated renewable energy efficiently from remote location to that location where it is needed and where it is to be integrated into the grid. Another problem is to maintain the system reliability and stability. To ensure that systems are reliable and stable, we need a proper technology such as real-time monitoring and control systems. And like Savle sir mentioned in his inaugural address is the cyber security aspect. So that needs to be addressed as well, because more and more when we are moving to the digitalization, then more and more cyber security aspects are there. So that needs to be addressed as well in standard as well as in the real time scenario. Another is the regulatory challenges. So for that we need some supportive policy frameworks and streamlining and regulatory processes. So I think that topic will be covered in the second half session. Now why standards are important in this particular power system interconnection? Like the challenges I have mentioned, all these challenges can be addressed through the standards only. For example, if standards are in place, they will define the proper guidelines, the proper technical requirements, the values of voltage frequency that needs to be maintained, how cyber security can be addressed. So all of these things, all of these challenges can be addressed through the standard. The standard will ensure that your power quality is intact, because they will define the limits for the harmonic voltage, microgrid fluctuations and everything. And thereby standards will play a very important role in power system interconnection. So particularly if we talk about the standardization in the field of grid integration, so that has been covered by the ETD 46 of BIS, which is grid integration of renewables. It is also a mirror committee of IEC SC 8A and SC 8B, and the scope is to prepare standards in the field of grid integration. So this committee was established around 3 years back, and since then the proposal was moved to adopt IEEE 1547. So since last 2.5 years, the committee really struggled a lot to review this standard and to adopt and to make the country specific changes. So as many of speakers have mentioned that IEEE 1547 is particularly based on 60 Hz frequency. So this standard that we have adopted 1547 is being adopted with the name of IS 18968 2025. So this standard we have developed a national annexure which is tailored to Indian conditions, including adaptation to the 50 Hz grid frequency. So this effort was being taken up by the ETD 46 sectional committee. So this is a modified adoption of IEEE 1547 2018, and this standard basically a uniform standard for the interconnection and interoperability of DER with EPS. So it gives the requirement relevant to the interconnection and interoperability, performance, operation and testing, and to safety, maintenance and security consideration. So this is a global standard that is now available on BIS website, and you can download it from BIS website at a minimum cost. Another standard that is being adopted by BIS in this series is IEEE 1547.1, which defines the test and procedures for verifying the conformity assessment of the interconnecting equipments of DERs with EPS. So this is also modified, and in this standard also we have added a national annexure to define the related requirements for 50 Hz and to define the country specific changes. Another standard in this series is adoption of IEEE 1547.7 2013. It is a direct adoption. There is no changes in this particular adoption. It is a guide for conducting distribution impact studies for distributed resource interconnection. So it provides and describes the criteria, scope and methodology for determining which engineering studies need to be performed to assess the potential impact of DR interconnected to an area EPS distribution system. So this is an equally important standard which is being adopted by BIS recently. So now what is in the pipeline, and ETD 46 is now developing the standards on the subjects like the terms and definitions of the grid integration of renewable energy generation, then power forecasting technology, which is another subject, is in pipeline. Grid code compliance assessment methods for grid connection of wind and PV power plant. This subject, another subject, is also in pipeline for developing of Indian standards. Then we have already talked about IEEE 2800, so that is also under consideration in ETD 46, and technical committee members are reviewing this standard also for defining the country specific changes. And another subject is grid connected solar rooftop PV. So this is these are the subjects which are under pipeline for the development of Indian standards. If you feel that there are certain areas which we have not touched upon till now and which needs to be standardized and a standard needs to be developed on those particular subjects, you may please feel free to send your proposal to BIS through BIS website, or you can also mail us to etd@bis.gov.in. So in this particular ecosystem, when we talk about the grid integration with renewable, there are challenges that I have mentioned. So those challenges can be addressed by these standards that are being developed by our Electrical Energy Storage System Sectional Committee, ETD 52. So ETD 52 is also a very important sectional committee and will play a crucial role in the whole ecosystem of this grid integration. So I would like to talk about two important standards that are being developed by the sectional committee. One is 17092, which defines the safety requirements of electrical energy storage system. So this standard covers the different types of electrical energy storage systems such as electrical, mechanical, chemical, and so these are the electrical energy. So this standard defines the safety requirements of all of these, define the tests and procedures to ensure that these electrical energy storage are safe. Another important standard that is being developed by the sectional committee is 17387, which is for general and safety performance requirement of battery management system. So battery management system will comes into picture when there is a battery energy storage system, in order to ensure that this whole system is safe and working under controlled conditions. Another areas that I would like to touch upon is the ETD 13 and LITD 10. So ETD 13 is the equipment for electrical energy measurement and load control. Like Savle sir mentioned the topic of smart meters. So for that, this committee has developed two important standards, IS 16444 series, which is AC static direct connected water smart meter class 1 and 2. So this will also play a crucial role while designing your smart grids. This is one of the equipment, one of the component of the smart grid. And another is the IS IEC-61970 series, which is Energy Management System Application Program Interface. To address the cyber security and to interoperability, interchangeability, we have one committee under our Electronics and IT department, LITD 10, which is Power System Control and Associated Communication. So this committee has also adopted some IEC standard which addresses the cyber security and interoperability thing, which is IEC 62351 series and 61850 series, which defines the communication network and systems for power utility automation. So all these standards will become the part of this whole ecosystem of grid integration with renewable. So thank you, that's all from my side. Thank you.
Thank you very much for elaboratively talking about the standard development process and also addressing all the standards in the entire value chain, right from the generation, distribution, storage. I think it was really a great work that is being done by BIS. Congratulations once again. I also would like to congratulate TTD 52 for taking up the energy storage system standard and also BMS standard, which is first of its kind across the globe. I think that's a commendable work that has been done by BIS. Thank you very much, and if there are any questions.
Thank you very much, Neha, for a very clear presentation about a well-established, for a long time, BIS, and well-organized with 46 groups within the electrotechnical division. My question will be about regional standards versus international standards. In some part of the world, for example, Europe, the European Commission has made a decision that Europe will not develop standards if an international standards exist on a given topic. And before the European organization in charge of the development of standards, if they wish to develop a standard on a new topic, they have first somehow to check or demonstrate that there is no international standard existing. Of course, there are some exceptions. Europe can develop standards if it's about environment or security that normally can be specific. So, well, that's one example. I'm not saying this is how it should be done worldwide, but I'm intrigued by, you've been showing a BIS process to develop BIS standards, starting from a NUIP with different stages. The point is, when you're about to start a new standardization project, how do you make the decision to whether consider an existing standard somewhere or an existing specification from an alliance somewhere, or start from scratch and developing your own BIS standard? What, is there a process? How is it decided?
Okay, thank you, sir, for your question. So, as I mentioned in my presentation, that as far as possible, we try to harmonize our Indian standard with respect to IEC and ISO. But in some of the areas where we feel that there are some tropical conditions are there, in India, the temperature varies from -10 to 55 degree. So, we need to consider the environmental condition as well as the temperature condition in order to bring international standard in line with our country specific conditions. But when we receive any new proposal for developing any new standard, then we always examine if there are any standards available at the IEC or ISO at the international forum, or if there are any guidelines are available or published by SIGRE or any other scientific organization, if there are some reference material is available, and that's how we decide to develop the standards on the subject.
Well, for example, for the environmental conditions of operation that might be very harsh. In India, actually, India is as an IEC, India National Committee, with a lot of experts from India participating in the development of the IEC standard. So I'm wondering why the environmental conditions of India would not have been taken into consideration in first hand in the development of the IEC standard.
Yes, so when we receive the ballots from the IEC for submitting the comments, so there we always insist that IEC should include the environmental conditions to cover the global scenario. So there how we are trying to cover up all these requirements that pertains to Indian condition into the IEC standard. So we do not need to mention the national changes in the national annexure, and we are able to directly harmonize the Indian standard with the international standards.
Yeah, thank you. Thank you very much.
You can also add.
Thank you. Thank you very much, Richard. Is there any further questions from anyone? Right. If there are no questions, thank you very much, Neha ma'am. It was really elaborative. Now, may I request Mr. Amarjeet Kumar, the founder and CEO of Comminent, who is going to talk about, I think, the communication, why communication is most important, and how the standards can facilitate it, and what kind of things that we really need to look at while we are developing these standards for this. Over to you, Amarjeet.
Thank you. Okay. Thank you very much. First of all, I would like to thank ISGF and ISUW to host me here, invite me here. This is my 11th ISUW I have been attending, and this is my 9th session of IEEE IEC, which means that I have attended every single of it, most experienced here. So let me just set some context. I have been listening from morning. We have been talking about getting to developed nation by 2047. We are talking about tripling the per capita energy consumption. And but how do we achieve it? I mean, can we do it without the people sitting in this room, which is standards? Can we do this without a standard body? The answer is absolutely no. In order to make a country to the level where we want to take it, you just don't have to grow for yourself. You need to take a leadership role where you are not only growing your own country, you are growing others along with you, and that is how you become a developed nation. You cannot just become a nation where your nation is developed on its own. It has to be a collaborative approach, and which means that we have a habit of, unfortunately, but we have a habit of being a reactive society. We react to things. If we are thrown a problem, we do find a solution. We have a very good track record of finding a solution if the problem is thrown to us. But if we basically don't take a proactive approach, now that has to change. You need to, whether this is a mindset, I would say, whether we are talking about backward compatibility, that needs a proactive approach. Whether we are talking about growing a nation, it has to be a proactive approach. So that proactive approach has to come. What I have seen, I have been part of various standard bodies in last 20-25 years, whether it is, I think I am one of the persons sitting here who is involved in most of the standard bodies here, whether I am part of BIS LITD 28, convening a committee there. I am part of IEEE, I am part of working with IEC also, with some of these other standard bodies, the industry consortiums. I represent Voice and Alliance. I have been part of Zigbee in past. So yeah, I mean, I have looked at the whole spectrum of it. What I have seen as part of Indian ecosystem, we are one of the most reactive community here. We react when something is thrown to us. Now that habit has to change. We need to be proactive. We need to get involved. If I look at other competing economy or the set of people like US, China, I mean, how did they grow? They have created these standards. If you look at their participation in the standard bodies, and it's not just the government. We have a habit of blaming the government that we are not getting that, but actually it is us also, the industry people also. We need to understand that we need to, if we want to grow ourselves, grow our economy, I think we need to just change from Make in India to Make in India for the globe. So, right, I mean, and that can happen only if we are following a standards. We cannot build a product for India and then sell it outside. We need to consider the holistical things and get involved in this standard activity more proactively instead of reactively. So that's with that. My discussion, what I have is, my background is basically communication systems. So I have been developing communication systems for last 20-25 years. So my talk is limited to communication systems, And since this is future technology, what we are talking, I have picked up two, the latest technology what India have adopted, and globally this is the two most talked technologies, or the area where the whole industry, at least in the utility sector, is being talked on. So first thing I want to talk about the importance of communication system and cyber security, right? So within this whole system of smart grid, smart system, smart utility, and lot of smart infrastructure we are talking about here, I want to focus on communication system, the network communications, what we are talking about, how important that is, and what is the importance we all should basically pay to that, and in case of communication also the cyber security. So that's the first thing I want to talk about. Second is the two technology which I have picked. One, again, everyone is talking about 1547, but I want to focus more on the cyber security part, which is 1547.3. The second one is IEEE 2857, that is for the large scale IoT network for all your grid connectivity or smart metering, all the smart utility use cases. So these are the three things which I'm going to talk about. Before I start, one of the question I would like to ask, if anyone can tell me the oldest communication network you know of. Any communication network which is the oldest communication network what we have seen on the planet Earth. Anyone can say? No, before that. Before that. Your human body. Your human body is the live example of a communication network, right? It's the world's first communication network which is not built by humans, it is built by the one who created all of us, right? So that's the importance. I have picked up this picture to basically showcase the importance of the communication network. If you remove this, can you have your body functional? The answer is no. So the idea of putting this picture was to put the importance of communication network in any of the smart network. We are in an age of digitization. We are talking about digital infrastructure or everything smart, whether it is a car or a house or a fridge or a city, everything is going to get smart. But how are we making it smart is the basics, the backbone of the whole thing is basically this communication network. If you remove the communication network, nothing is smart, right? So in order to make anything smart, we need to pay utmost importance to a communication network what we are putting in place, which means that we need to understand our requirement, what is my data rate required, what is my range required, where are we going to put, what is the availability, what is the SLA we need, all those things we need to put in place before we pick up a communication technology. If we are going to put up communication technology and later we are going to find out that, okay, this doesn't work for this particular use case, you are going to remove everything and put a new communication technology. Now that is a painful thing to do. So the first and foremost important thing is to pay the most important importance to the communication technology requirement what we need, and more communication, more and more digitization what we are talking about, more and more threat we are opening up for the cyber security hackers. So the cyber security comes along with communication infrastructure. Now we cannot have a communication infrastructure and build the cyber security on top of it. The cyber security has to come along with the communication infrastructure what we are putting. What I have seen lot of deployments where we are not paying the importance of the cyber security there, and later point of time we find out that, okay, this is not good enough, can we have a new standard? So those are the important thing I just wanted to highlight before I talk about the two standards what we have on the table. So when we talk about 1547, we have talked about everything here. I don't want to talk the same thing again, just highlighting few of it. So this DER is a little different if you look at other communication. I'm talking from the communication perspective. It is little different because here it is what we are doing is we are connecting various ecosystem to one another, which means that one vendor is not going to produce all the components. So we are going to to produce multiple components, and then we are going to create a network where each other has to talk with each other, right? So now each vendor is going to make their product their own way with their own preferences, choices. If we don't have a standard there, it is bound to have a mess there, right? Mess in terms of the capital investments, mess in terms of the integration activity, mess in terms of the cybersecurity issues, right? So we need to pay very much attention when we are talking about this 1547 or DER, that we have to follow a certain standard, certain guidelines in order to avoid those issues which we are going to face in future, and especially when I'm talking about the cyber security. So we are in a place where we have to pay focus in terms of the interoperability issues. We don't get into any kind of cross-organizational integration issues. So those are some of the aspects which 1547.3 takes care of it, which is basically by providing the objective means for evaluating your effectiveness of your cybersecurity controls, you're identifying the weaknesses, vulnerability in the system. So all these things are basically part of this 1547.3, which helps us cover those gaps, fill those gaps, and build a robust solution. I'll go for the second one, which is IEEE 2857. This is another standard I wanted to talk about, which is actually, again, like in case of OCPP, a lot of work done, and then later it was moved to IEC as one of the IEC standards. In case of IEEE 2857, the issue we took up is basically the large-scale IoT network using the RF mesh technology. There we had, even in the morning, Savle sir was also mentioning on the gaps there. So there we didn't had a system level standard. We had standard at the physical layer, we had some MAC layer, but the system level standards were missing. That's where within Wyson Alliance, we started this work of creating a field area network specification. And once that work was done, it has been basically adopted by several SDOs across the globe, including IEEE. IEEE adopted that as IEEE 2857. Lot of national level SDOs have also adopted, including India. So in India, we have adopted it as IS 18010-4-1, which is under LITD 28. Also, this is currently being discussed under IEC ISO. So that is also work in progress. So what we are trying to do is we develop a standard, but we basically then open up for all the global SDOs to basically make sure that it is accessible to everyone. That's the most important. Having a standard which is not accessible is of no use. So that's where we are basically pushing it to all the SDOs, making sure that it is available to all the ecosystem. Again, I'll give you an example of reactive and proactive thing. As one question was asked, Richard asked, the last presenter to BIS, that why it was not taken care, the environmental thing at the first place, right? Same thing have happened, whether it is 50 hertz, 60 hertz, why it was not taken care earlier. It has to do through an amendment while adopting by BIS. That is also a reactive approach. When I was doing this IEEE 2857, India have a sub-gigahertz spectrum 865 to 867 megahertz. But when we went to IEEE, that was not seen in the standard anywhere. So that again, we had to react. We went back to IEEE, we got it amended, we got it included. So that is the approach I'm trying to highlight, that we need to leave that habit of reacting, we need to be proactive. We need to start involving from day one to make sure that standards, what we are building, is for India. Also, we can build products in India for the world. Now that can happen only if we are proactively involved when the standards are being done. So that is another thing I noted when we were talking about 50 hertz, 60 hertz and this environmental, that I also had to do the same thing when I was doing 2857 and 15.4 standards there. Also, we have made some progresses. Good news for Indian ecosystem that last week we have announced our first set of certified products for the Indian market, which means that Weissen fan certified products are available as we speak in India. So that's a very good news that we are making good progresses. So we have products certified from our company, Comminent, Silicon Lab, and Renesas. So that's very good news. And we have just started. We are warming up. So we hope we will have much more set of vibrant ecosystem in coming days. So that's for people who don't know Weissen fan is, I have couple of slides just to highlight that. So Weissen fan is basically, it's Weissen fan, or you can say IEEE 2857, or we can say IS 1801-4-1, all three are same. So it's a RF mesh network system level standard, which is for large scale IoT network, which includes AMI applications or EV charging, communication network, or distribution automation, and many more. Many of these smart city applications like your garbage monitoring, people have used this. This is like your Android OS. Now you see a lot of apps coming up, right? So this is just infrastructure. You can have many applications which fulfills the where your network requirement is being fulfilled by this technology can come on this. So those are some of the use cases what we are building on. Some of these I have put just to showcase that whatever we are talking is being actually utilized and being deployed across the globe. It is not something on paper. It is already being deployed in PG&E. We have in Florida Power. We have it in BC Hydro. So we have so many other applications we have done in, I think in London we got street light also done. So there are so many deployments happening across the globe on Weissen fan. So this is just warming up for us. And we see a lot of deployments coming up in coming months in India also. So that is also on the card. So I'm hoping that in another quarter, we will have some announcement of Weissen fan deployments in India also. So this is also one of these projects going on in US. So with that, that is what I had prepared for today's talk. Any questions?
Thank you very much, Amarjeet.
Yeah.
A big round of applause. And is there any question from the audience? Yeah.
Well, if anyone else wants to ask a question, I don't want to be the only one. I can go?
Please go ahead.
I know, well, very, very sharp points, and thank you very much for sharing all the experience, the deep experience you have. I was curious about the cybersecurity standard that you mentioned, the 1547.3. If you would have any insights to share with us, comparing it with the IEC 62443, which is the IEC standard about all about cybersecurity for industrial systems.
Right. So when this 1547.3 was being worked, if you look at the standard, if we open the standard, it has listed at least 10 or 15 standards which it has, which the committee has gone through while creating these standards. So the IEEE working group had actually gone through all these standards and make sure that all these standards are taken into considerations. This is more of a framework or a guidelines kind of a document where how all these standards has to be harmonized. And I think it is well taken care of in terms of existing all the standards from IEC or other standard body NIST recommendations. So those things are already part of this 14.3 standard. Yeah.
Yeah, my question was about any insight. For example, well, I was about to mention the NIST framework.
Yes.
Where it exists, it's well documented. There's a lot of practice, a lot of return of experience. So basically, what this IEEE 1547.3 is bringing on top of that. It's not just republishing. It's not just chewing again a couple of other documents to bring up a well-written document. So what would be the specific points or specific viewpoint or the very good reason to actually invest and try to apply and reference this 1547.3 rather than investing in this NIST framework or the IEC-1. I mean, I'm not just saying the IEC is great. To me, the NIST framework is fantastic.
No, I mean, all the
Amarjeet,
standards.
May I
Yes,
interject
yes,
here
please.
because in the interest of time, maybe since it's a very specific about a standard, we can have the discussions later because we are running out of
No
time.
problem.
Yeah?
I'm here.
sorry,
so
Richard.
can
That's
talk.
good to me. No,
Yeah.
no
Yeah.
problem.
Thank you. Thank you very much. With that, Amarjeet, thank you very much for a very elaborative one. And also emphasizing on the collaboration that is required.
Yes.
Thank you. Now let me call Mr. Demerle from Alliance Partnership, who is the Director Marketing from LoRA Ecosystem, to talk about the work that they have been doing in this area. Again, particularly talking about, I think, the IoT and the security-related aspects. I think you left yours.
Hello, everyone. First of all, I want to thank ISGF for giving the opportunity to the LoRa Alliance for being with you today and to give you a view of the LoRa Alliance work with the LMS Association. My speech today will focus on how LoRaWAN is ready to scale for supporting smart electricity metering. I will also explain a bit the history, the members, and also the technical aspect of LoRaWAN. The presentation.
Unless you are talking for Ravi, it's the wrong presentation.
No.
Not this.
Is that on a computer?
presentation
Wrong.
put up the next presenter's deck.
I don't have any deck. Yeah.
He's doing it.
Okay. So, meanwhile, the LoRa Alliance was created in 2015 to offer for IoT the specification of the network protocol that is today used by many companies. It's more than 400 members participating to the LoRa Alliance. Thank you. So, for introduction, my name is Remi Demerle. I'm working at Semtech. I'm also chair of the Smart Water and Energies Work Group in the LoRa Alliance since 2018. And here today, I will give you a first view about the LoRa Alliance. Can you put in full screen? That will be more comfortable for watching. So the LoRa Alliance is a non-profit association. Thank you. It develops and maintains the specification of the network protocol that is using LoRa radio. It's recognized by the International Telecommunication Union. It's also proposing a program for certification of end device, which ensures interoperability. It's agnostic in terms of application. And this is the reason why we need standards such as DLMS, for example, to propose a smart metering solution. The governance of the LoRa Alliance is composed of a board with companies that are from either operators, meter vendors, system integrators, gateway manufacturers. It represents a vast ecosystem. We have also members who are utilities like Netze BW from Baden-Württemberg in Germany. We have also satellite companies like EcoStar Mobile using LoRaWAN for IoT by satellite. We have semiconductor manufacturers like ST Microelectronics, Semtech, and others. The ecosystem of LoRa Alliance also encompasses universities, research center, and test lab who are proposing certification for end devices. In India, we have several companies like Tata Communication, N2 Technologies, Ripple Metering, but also CareLink, Activity, Vipertech, and many others who are proposing LoRaWAN deployments in India. It's one of the largest reference in the world in terms of number of antennas already in use. For Tata Communication, it's more than 11,000 antennas over the country. The ecosystem, as explained, is composed of 3 parts: the end device, the network equipment, and the application server that can be, for example, for metering head-end system using the NMS protocol. We will see that. And in between, you have the gateway equipment that can come in different flavors, different models, from indoor to outdoor, that are capable to support many devices. LoRaWAN is also a protocol that is used bidirectionality, that is using bidirectionality for enabling the utility to control the end device, that is empowering the end user, for example, to initiate or stop some device at home. It's, for example, deployment in smart water metering, in smart gas metering, which accounts for millions of sensors. Today, for example, in India, with Managar Gas Limited, IGL also, we have field deployments for gas metering. We have also example for sub-metering with Ripple, for Bangalore Airport, and for many other commercial or industrial companies. The devices that are made by meter vendors or IoT sensor are many. It's more than 700 certified devices available on the marketplace of LoRa Alliance. And for the semicon part, chipset, module are available. It's a multi-source vendor ecosystem. One of the most famous applications of LoRaWAN today is water metering, and it's no surprise that the Ministry of Housing and Urban Affairs of India, in the 4th edition of the manual for water management and water distribution, is including LoRaWAN among the LP1 technologies for smart metering. It's also in use in Europe, in America, but also in the rest of the world. Few examples, for example, in France, it's more than 3 million of water meters with Veolia. In UK, it's 4 million of water meters that are going to be deployed across different operators. One key aspect of the choice of LoRaWAN for metering is the ability to have reversibility of the operator, to have also flexibility in the network deployment. For example, utility can start small and scale up, can increase the density as well, can have also extension of network coverage with relay system that helps to maximize. In building automation, it's also very well used. For example, indoor air quality sensor are application that today in Canada, in Philippines, in India as well, are very common. For example, to monitor CO2 level in meeting rooms. That could be ideas for shows or conferences as well. Supply chain, smart cities, many examples exist over the world. Calgary in Canada, for example, is one of the flagship cities, having used LoRaWAN for many applications: smart parking, waste management, street lighting, and so on. In agriculture, one example, for example, for apple farming with irrigation monitoring in Uttar Pradesh is already in use and with success. So LoRa 1 is pervasive, is disrupting because it's easy to deploy, and it also allows many different applications. But now with the challenge of smart metering, we understand that there are a couple of advantages that translate into real value for the utilities. One of the first key points is the ability to have a flexible network models, allowing also to minimize power consumption for end device. For an electricity meter, that will not be the first key point, of course, but for equipping a smart electricity metering solution with a DER device, such as for a remote plug, for switching on, switching off valve, for management of pump system, etc., then low power communication can be more important. It also supports two-layer security, giving to the end user the control of the application payload, and to the operator the responsibility for authentication and integrity of the transport of communication data. There are 3 available communication classes. One which is made for very low power consumption. The device communicates and sleeps most of the time. The other mode is with beacon, and the third mode is continuous transmission, which is, of course, the one preferred for smart electricity metering. Going to the history, in 2018, I remember at that time where we were identifying, especially with Tata Power, the need for support of DNMS. We were, of course, realizing LoRa 1 was agnostic, and then it was necessary to create a liaison with the DNMS association to ensure the LoRa 1 protocol could meet with the requirements of DNMS. In this effort, with companies such as EDF, Actility, Orange, Cisco, and Semtech, we created a common group to work together and to deliver a solution that could meet the goals and reduce the challenges. One of the key challenges required by DNMS Association was to support IPv6 and UDP protocol. So to allow that on a constraint protocol such as LoRa 1, the choice was made to use SHIC technology, which is defined by Internet Engineering Task Force. This technology, which has been developed in the last decade, in 2019, and created with here LoRa 1, a first use case, we can solve the problem of transporting the headers for static context application, typically a smart metering application. The communication stack has been fully standardized with the use of this IETF layer for SHIC, static context header compression, which is based on RFCs, and using the LoRa 1 protocol underneath. IEC has adopted the DNMS profile for LP1 in the release in 2023. So from that perspective, I wanted to say it was, of course, heavy lifting to regroup companies, to work together, and create the ground of a standard that is today already available by IEC, but also ready for certification. A couple of examples, and we will make demonstration during the exhibition in the next 3 days. It's here an example where every brick is interoperable and can be replaced with, I would say, the ability to communicate from end to end with DNMS. You can have either push or get. You can, of course, transmit the different data that are necessary by the utility. The value of having IoT in the smart meter is also opening the chance for one-to-one communication between the meter and other device at home. It's also the capability to have complementary media, for example, PLC plus wireless. It's also the ability to have mixed of deployment with, for example, cellular and LoRaWAN to cover the different areas. I will give you one example. Here we see also the flow chart of the data through the different interfaces. In this use case, using DNMS over LoRaWAN in Italy, the DNMS standard is required by regulation. And Italgas, who had started to deploy with NB-IoT, faced with challenges in connectivity. They decided to change and have a new generation of smart gas meters that will embed the two connectivity, but still using DNMS as a common application protocol. So the project is passing now the end of the pilot with 30,000 units on the field, and will go for massive rollout starting from the second half of 2025. So what we here see is the advantage of supporting common standard and having, I would say, the problem of coverage solved with the two connectivities. Certification are now available by the LoRa Alliance for the LoRaWAN part plus SHIC, and by DNMS for the DNMS profile. All references are here available for those who want to dig into, but we are also available over the next 3 days on the booth in the exhibition floor. Thank you very much for your attention.
Thank you very much, Demerle. I think I'll limit no questions now because we are running out of time. Maybe we can have discussion over lunch. Thank you very much. And now may I request Ravindra Desai from IEEE to make his presentation. Sorry, Ravindra, I think you have a limited time.
Good afternoon, friends. I'm Ravindra Desai. I'm Program Manager, IEEE, rather IEEE Standards Association, and I'm with the India office, or rather IEEE India operations. Okay, we are talking about energy technology. So the global trend towards energy transition is cleaner and sustainable energy. The energy may be renewable, solar, wind, or maybe geothermal, or maybe storage, hydrogen, or battery system. Okay. Okay. So why standards matter in smart energy? For that matter, for any energy technologies. One is interoperability, which most of the people spoke. We have different systems, so they should seamlessly communicate with each other. And cyber protocols, we are facing more and more cyber threats. Okay, operational safety, I will not talk more on this. Data with more devices and sensor generating vast amount of data. It's very important to standardize the way data is recorded, it is transmitted and interpreted, which makes monitoring and control easy. Okay, then grid integration of renewables, which we'll talk maybe in little detail. Scalability and flexibility, cost effectiveness, and last but very important is regulatory compliance. See, IEEE 1547 in 2018, that is the latest version, which is the standard for renewable grid integration. Okay, it's a global standard, and it is adopted for by BIS. Okay, and India has a target of around 500 gigawatts by 2030 of renewable integration. Okay, so this is Neha, the BIS representative, plus I think others also said, including Manju. This almost took 3 years for the adoption, and the committee went through rigorous deliberation on adoption of 1547. And yes, there are 50-60 question is there, which I may answer later, but this is mainly adopted for the functionality. Okay, so there are features which help adoption of this 1547 by BIS as IS 18968 2025, maybe a month back. So some of the good features of 1547 are enhanced grid stability and reliability. So it supports voltage and frequency regulation. It supports right through, or it has features, okay, provisions for frequency and voltage right through, whether it is high frequency, low frequency, or high voltage, low voltage. 1547 has the provision for scalability. You can increase the penetration of renewable DERs into the grid, flexible grid management, okay, improved power quality. Okay, so it has settings for the harmonic distortion, maybe flicker or voltage fluctuation. Okay, very important is anti-islanding protection for the DERs which are connected to the grid. So it has the provision or features in case of de-energization of the grid, it will stop supplying to the grid. Resilience, better grid operation and control. Economic environmental benefit, cost saving, okay, consistency and simplification, or rather this whatever are the technical requirements which are globally applicable, enhance safety and utility, enhance safety and future proofing of grid. So these are some of the features of IEEE 1547 2018. So similarly, this is for the distribution level, that is up to 33 kV, or sorry, 35 kV. So similarly, on the line of 1547, there is one more standard which is at the transmission level, which can be used for 69 kV and above, up to 500 kV or 500 kV above. But features are almost same: enhanced grid stability and reliability, facility for high renewable energy penetration, improved power quality, increased operational flexibility, enhanced grid resilience, a lower integration cost. It facilitates advanced grid services, better coordination and communication with the help of 1547.3, which Amarjeet mentioned. And the latest version 2023 includes it addresses some of the aspects of cyber security, 1547.3, future proofing, economic and environmental, and improved safety and security. So I will not take more time. So this is adopted by BIS, and some of the changes, okay, which are incorporated in the BIS adopted standard, that is IS 18968. One is frequency, so in place of 60, the standard will use 50. Okay. In case of voltage, single phase 120 and 3 phase 240, it will address single phase 230 and 3 phase 440. Frequency, so when it talks of frequency, like table 3, minimum measurement. So 1547 talks of 50 to 66 hertz, whereas for Indian condition it will be 40 to 55 hertz. Okay. And the service criteria. So 1547 talks of default setting as 0.917, whereas for Indian condition the panel use this setting for the Indian condition, it is 0.9 per unit. And the range of setting 1547 is 0.88 to 0.95, but for Indian conditions it is 0.8 to 0.9. The maximum value 1547 is two settings are there, 1.2 and 1.1. Okay, whereas we have only one, it is 1.1. India, the setting is 1.1 to 1.2. Frequency it is 49.5 and maximum is 50.1. Okay. Whereas for 1547 or 60 hertz it is 59.5 and 60.1. Okay. So there are almost 40 plus tables, almost all the tables remain same. Here also, just to give an example, it is table 3, almost everything remains same. If you can see to frequency, the minimum measurement is 10 millihertz, and only the range, frequency range changes. 1547 is 50 to 66 hertz, whereas for Indian condition it is 40 to 50 hertz. Yeah, one more. So when it comes to reactive power injection and absorption, 1547 says it is even as per ANSI it is 44%, whether it is injection or absorption. But as per and these are taken as per CA and MNRE guidelines. But for Indian condition it is whether it is injection or absorption, reactive power it is 60 hertz. So there are three different categories 1, 2, 3 in 1547. But for Indian condition, we have combined it into over voltage and under voltage, that is 1.1 and 0.8. Whereas 1547, it is two level. Over voltage is 1.2 and 1.1. And proportionally the timings are different. I think 1.2 it is 0.16 second and 1.1 it is 300 seconds. Under voltage also for Indian conditions we have the under voltage is 0.8 with 2 seconds setting, whereas 1547 the under voltage is 0.7 and 0.45. Yeah, proportionally the timing changes. For 0.5 it is 0.16, 0.45 under voltage, the tripping is 0.16 seconds. Okay, and for 0.7 it is 2 seconds. So over frequency there it is 62 and tripping time we have kept the same, it is 0.16 second, and for under frequency it is 57.5, whereas for Indian condition it is 47.5. Okay, and the frequency disturbance right through is, it's a long which gives reference of NERC, NERC and FERC, okay, or ANSI. So we have, for Indian condition, we have concised it to 50.05 to 50.52 megahertz, hertz, and range from 47.5 hertz to 52 hertz. Okay. Yeah, thank you. I try to keep my presentation
Thank you very much,
short.
Ravindra.
Yeah. And
any
the
time. Thank you very much. And if there are any questions, you really covered the India differences very elaboratively. And definitely, as Srikanth was talking in the morning, there is a need for assessors, the training. We can work on that, having those specific workshops. If there are any specific questions, maybe only one question.
Yeah, you rightly said. I think this is a highly critical area, DR integration with the grid, and I think friends from the utilities will know the criticality of this. So yes, there need to, I mean, we need to have qualified assessor to see that grid integration complies to standard, whether it is IS or IEC or IEEE. It should comply to standard, then only it should be integrated. So I support that statement. Even it should come in the regulation or in the policy. So my friends who represent CA or MNRE or any government agency, they should take note of this, that this should come into the regulation also. Okay.
Thank you.
Thank you.
Once again. And now the last speaker, Dinesh, no pressure, but however, I would request you to keep your presentation 15 minutes so that we can have the question and answer and the concluding session. Thank you, Ravindra.
Thank you very much.
Dinesh Sharma, who is the director with SESEI, SESEI, the way we call it. He is going to share his experience on the European context. Dinesh, over to you.
Presentation. Thank you, Manjunath. So effectively, I have 15 minutes. Huh?
Thank you.
And you will run the session until 1:30. So please wait for your lunch until 1:30. We have to wait. We should wait. But presentation, please. But so far, we have heard about all these standards. I will not touch upon the specificity of specific standards, but I'll give you a helicopter view of how this sector has evolved in Europe. I mean, of course, we started with metering, we went on to grid, then we talked about smart energy, and now even we are talking about all electric society. So in my presentation for next 15 minutes, I'll give you a brief background where we are and where we want to head up when we talk about smart grid or smart energy or all electric society. Yes, of course, I think since morning we are talking about, we have various alliances, we have various SDOs, and idealistic situation is that we should have a global standard, which is IEC standard, specifically talking from a electricity point of view. But then we need these alliances, because at the end of it, I think this question was popped up in earlier question. We need to make it backward compatible. We need to ensure it is backward compatible. But situation arises when we take a call that where we are heading. And I think in Open Charge Alliance, this presentation was very clear. They wanted to align with IEC. So that's why probably 1.6 to 2.1. It went on like that. But at the end of it, it is industry which work together, which develop these standards together. And they take this call, whether we need to have a revolution or an evolution. But in case of standardization, we always talk about evolution. And when it is an evolution, we make sure that it is backward compatible. So let me go back to my presentation with that as an introductory remark. I think I was briefly introduced, but I work on all these sectors. I started working with sense analog organizations way back in 2012. And since then, I was also involved with ISGF. We worked very closely with ISGF. We had an MOU with them. We are still continuing cooperation in the field of electricity, but I also handle the other side of the coin, the digitalization, because nowadays more and more we talk about smart. When we talk about smart, we talk about ICT. When we talk about ICT, we talk about communications, and that's why we have this LoRa, Bison, machine-to-machine communication, which is 1M to M, and then we have narrowband IT. So it's all connected, cross-connected. So I handle all the sectors where EU and India have an interest, and they would like to have an exchange. My job is to share what's happening in EU, and then India can take a call whether it makes sense to take learning from there. But the end of it, as Richard mentioned, EU has a rule that first we have to look into the IEC or ISO. You know, if any subject pop up because of the act or regulation in EU, we always see a global standard first. EU has to make sure that it works with international organizations, and we have a global standard. So I work on all these sectors. We have a website. I release a newsletters if you're interested to know about it, because my job is to work with Indian side, share EU report or status around those standards with India, and same thing, collect it from India and give it to the EU. And then we have some success stories around adoption as well. As I said, in EU, through a regulation 1025/2012, there are 3 officially recognized standards organizations. CEN, which is a counterpart of ISO in EU, CENELEC, which is a counterpart of IEC, and then we also have ETSI-ITSI, which works on these 6th generation, 5th generations like GSM related, mobile phone related standardization. And that works with the 3GPP and 1M2M partnership project. So they are supported by the regulation, which is right now going through a review right now, because they would like to update this old regulation with the latest requirements and needs. It is getting reviewed right now. Let's go back to the CEN CENELEC. I will not be covering ITSI here because ITSI is not into the IEC related standardization. But as you know, CEN and CENELEC, they bring together the national standards organization from the member states. So all these logos which you see these are the national standards organizations which come together under the umbrella of CEN and CENELEC. And then through CEN and CENELEC platform, while working with the regulation or the act, they create ENs, European norms, which is harmonized standards. So effectively, if there is a law which demands a standard, or they publish that standard as a part of official journal, then there is one standard and the entire Europe is a single market. That member states will adopt that regulation. Through that regulations, the harmonized standard will become an implementing standard. So with that, they ensure the single market all around Europe. And that is a benefit which standards bring with it. You know, when you talk about electricity, you think about affordability. How would affordability will come? It will come only from economies of scale. And economies of scale comes the more and more wider stakeholders adopt a global standard. And that is the ultimate goal. This I think brought up in the morning, but they are very closely linked with the WTO principles. Globally, we have ISO, IEC and ITU. ITU into telecommunications. CEN and CENELEC are closely interlinked with Frankfurt and Vienna Agreement. ITSI with ITU through an MOU and membership. And if you go down further, these are the national standards organizations who work and come and work together. As I said, a very inclusive system representing all the stakeholders' voices, industry, SMEs, societies, to work together, including R&D organizations, to develop a standard. Sometime when there is no consensus at the IEC, EU has to develop a standard for the European market, and that's why you see there could be a EN existing but no global standard. But if there is a global standard, always there is an alignment, because these are the same people who develop those standards. On smart energy, I mean, I'm just holistically presenting this slide because more than grid and meter, we have to see it more from an energy point of view. Because all the regions, all the countries are committed to the Paris Convention. They have to reduce the carbon emission. They have to take care of the environment. While we are modernizing our grid, this is one part of an activity. So that's why we have many directives in EU which make sure that we have to comply while we continue our journey towards smart energy or modernization of the grid. We have energy performance of the building, because building is the guzzler of this smart energy. Then you have a renewable integrations, because at the end of it, we have to get rid of the fossil fuel. That's why the renewable energy directive is there. And then you also have an energy efficiency directive. At the end of it, efficiency also plays a very key role. Directives in EU are like a law. I mean, it's a law, it's mandated. And once there is a directive, there is a transition period of 3 to 5 years in Europe for its implementation. And that's how, once the directive is issued by the Commission, the national members or the national regions, I mean the member states, adopt that act. And that's how indirectly acts gets linked to the standards as well. Because in electricity, you have an aspect of safety. And when you have a safety, consumer safety, automatically these standards become a mandatory standards, and they come through a testing and certification phase of it. So these are the directives. To support these directives, there are various policy initiatives. We have a policy initiative in Europe called Clean Energy for All. It's a package which was released in 2019. There is also a strategy for energy system integration. Through this energy system integrations, there is a European Green Deal, which is a consolidated deal to talk about all the sectors, but energy system integration is playing a very key role down there. And in this, I mean, I have a limited time, but I can, if you read it, it talks about emerging technologies, processes and business models, how you're integrating the ICT and digitalizations while you are taking care of the grid and metering modernizations. EU also has an action plan for grids. There is a digitalizing the energy system through an action plan 2022. There is also a package called Fit for 55, which is nothing but it's a strategy which sets a goal to reduce 55% reduction target in the net EU carbon emissions. To achieve that, while baseline with 1990, while achieve that, they says that the renewable energy integration share should be more than 40% to achieve that. And that's how this is fit for 55 reduction targets. Recently, they come out with a Green Deal industrial plan and a net zero effect, again taking care of the energy as a key element or a key sector. Hydrogen is also becoming a very popular, I mean, of course, it is an evolving topic, both from a research and standardization point of view. But this is going to play a very important role when we talk about energy needs all around the globe. To achieve those initiatives, I mean, there is a strategy for hydrogen. There is also an alliance, they call it Clean Hydrogen Alliance in EU, and how it will be integrated as an energy system. There is a policy initiative. Clean Hydrogen Partnership has been established way back in 2021 to support the research and innovation in hydrogen sector. And Fit for 55 also include hydrogen as one of the energy sources. Then you have a renewable hydrogen. I mean, when you're producing a hydrogen, you have to make sure that it is produced with renewables. So we could call it as a green hydrogen. So that aspect is also taken care of it through this initiative called Hydrogen Initiative. For a standardization point of view, when you talk about smart grid or smart metering, you know there are different stakeholders. I mean, some ICT work is there, some interoperability aspect of it, some electricity aspect of it, more from a safety point of view. So in EU, we have called a coordination group. I mean, it uses CG. They make sure, it's a high-level group, they do not develop these standards, but they make sure there is no duplication of efforts between different standards organizations. And that's how they consolidate, they review these directives, they review these regulations, they study what has happened all around the globe. When you touch any new topic, not only ISO and IEC, if there is a standard, IEEE, good standard, let's study them. So let's include them, let's review them. Don't reinvent the wheel. Because if you will start from a scratch, it will take years to develop, to have a stable standard which could be implemented. And that's how we all are connected, we all work together to make sure do not reinvent the wheel. So we have this coordination group on smart grid. They had published a lot of standards. They have consolidated a lot of standards before they started implementing it. So there are various reports available on it. Initially, there was a smart metering coordination group separately, smart grid coordination group separately, but they decided let's have a smart energy coordination group, and that's how they are working together, and that's how they are ensuring that the work is done in a harmonized way. Not only in Europe, they also make sure that we have to be aware of what's happening around the world, including India. Like in India, I'm present. They also have different working arrangements with Japan, US, Canada, Africa, when you only talk about grid or a smart energy kind of partnerships, just to make sure that we work together. At the end of it, we all should work together to have a single standard, and that should be developed by IEC. Because we have regional requirements. It's not that, like, for example, India has a temperature requirement, India has a 50 hertz requirement, but those are very well safeguarded if you propose them. If you go and sit proactively, not reactively, but proactively at these platforms, at these technical committees, the regional requirements are also well safeguarded. Same exercise you did it. You adopted 1547, but then India had a requirement of 50 hertz. Then you created an annex. Sometimes those details are put as footers, sometimes put as annex, and that's how. But need to work together with the IEC platform or a global platform more proactively. This is some outcome. I have produced it. I need not to go. It's all hyperlink. This presentation will be shared, but you can have all the details about the library of standards which are available for smart grid and smart metering. You heard about it, Neha ji, and I think they are working very proactively these days. They are adopting these global standards proactively whenever the subject is proposed by the members, and I work with them very closely as well. Current activities, I would like, this slide is important. As I said, now more and more we're talking about all electric society. And you know that, everything would need electricity, whether it is industrialization, whether it is manufacturing, whether it is IoT uses. So they're trying to even consolidating more, especially e-mobility. I mean, e-mobility, charging infrastructure would need lots and lots of electricity. And we have to make sure that its integrations with the grid is handled properly. So they are now created this board group, which will be converted into a coordination group to ensure that when we do a grid modernization, integration of renewables, bring in any new sectors to the power industry, we have to treat it as an all electric society. And that's how they will make sure that the efforts are done in a very, very harmonized way. So this is how they will create this coordination group in the month of July. But right now, this technical body or technical board working group is active, and they are trying to consolidate all the efforts. And they will work very closely with IEC Study Group 14 to make sure that the efforts, the consolidation is well shared and well appraised to the global organization as well. It's just a snapshot. I mean, you can see how complicated it is. How many working group would you need to take care of these electricity or energy sector? The same color means there are some kind of synergy between them, but still you have many, at least 4 colors and number of technical committees. You have a low voltage, you have a medium voltage, you have a high voltage, you have a transmission grid, you have a distribution grid. It's a very big ecosystem. And every element of it works and develops standards for that. But that it need to be done in a very harmonized way with all other connected elements. But this is what the summary is all about, that in EU, which topic, which technical committee is active, and they are working with IEC, corresponding IEC technical committees while developing these standards. It's just a grid architecture model with a background that when they started developing the framework, this was the first and foremost things which they developed it for the grid architecture. And you can see that there was an interoperability element which was addressed, there was a domain address and the zones. So this is how they created the architecture to take care of all the aspect while developing this grid architecture model. This is, I think, we talked about it, Neha ji presented, 61850 is a very, very important standard, and even EU is giving equal importance as well while adopting and implementing these standards related to communication, power system management and associated information exchange. And I'm happy to see that entire series of 61850 have been adopted in India. But this is an important standard. It's just a quick snapshot that we are equally serious about this communication and interoperability aspect of it. ITSE also works on it. As I said, I think LoRa when talked about it. IoT element also plays a very key role when you talk about all electric society. For that, the work is done at a different platform, and ITSE does it. And that's how this Smart Grid Energy Coordination Group works with Sense Analytic to make sure that we all work together while developing it. Even there are cards, secure element technologies, there are technical specifications, because at the end of it, the communication also has to happen with the handheld or a mobile phone device, for which you would need a communication side of it. So even for that, there is a technical committee. Then you have a smart M2M, which is also developing an ontology while using the SRF aspect of it, smart applications side of it. With that, last Couple of slides. There are, in between EU and India, there are various partnership instruments where we exchange these dialogues, where we exchange these developments, and where we also ensure that we work together and contribute at the global platform. For example, there is a EU-India Clean Energy and Climate Partnership, which was started in 2016, and it continues year on year. EU-India Trade and Technology Council was established last year, February 2023. There is one working group which is dedicated on green and clean technologies, and where we also talk about standards. So there is a formal exchange between government to government as well in both policy and standardization. EU-India also has a partnership on smart and sustainable urbanizations, because India was developing 100 smart cities, and that partnership instrument also exists between these two regions. EU is also providing support to Indian cities to join global Comminent of mayors, and I think it's a good accumulation of partners, because this largest global alliance for city climate is bringing leadership from all across the globe. It is built upon the commitment of 12,500 cities. So more and more cities are coming together, sharing their practices, what kind of gaps and challenges they have, how they're implementing. So this is another alliance which India is interested to join, and EU is helping them to work together. So if I conclude my presentation, I could only say that digitization will play a very key role when we talk about modernization or energy system, and EU action plan is in place to make sure that digitization is completed in a holistic way. We all know standards play a very important role, not only in implementing smart energy, but now it's all electric society as well, because we always come across challenges, we always come across gaps, and we all sit together to address those gaps and challenges by bringing in these standards, because once it is a standard implementation, the risk and the challenges are minimized to its maximum possible. Coordination group is a very good exercise or a good practice in EU, and I think while we know that there are different technical committees work on this subject, setting up some kind of coordination group helps exchanging these work. Lastly, EU-India also have a high-level platform on smart grid specifically, so they do exchange on that as well. With that, I'll close my presentation.
Thank you very much, Dinesh. Thank you for keeping the time, and also it's a great, I think what you really brought out is the collaboration is the most important thing, and this is a great platform where all the SDOs are sitting together, coming with what are the challenges and what are the solutions, and also I think we identified many of the topics where the standards development is required, and also the standardization part. With that, before I conclude, I'll hand over to Chair for his remarks.
Okay,
Thank you, Manjunath, for running an efficient panel. We are at lunchtime now, 1:30. First of all, I want to thank all the speakers. We heard various different perspectives. We heard from standards bodies, we heard from alliances and implementation partners, and we heard about the Europe-India collaboration. I think we are at an inflection point where we really need to take this forward. I think we have all the elements in place today. We just need to go ahead and execute on the various priorities that addresses the goals of climate change, but also regional specific goals in bringing renewable energy to the forefront. With that, I want to thank all the audience who are present, and India Smart Grid Forum for providing a platform to provide this discussion. Thank you.
Thank you.
So I thank you all for your patience, and I know I'm standing in between in your lunch. I just request all the keynote speakers to please come up on stage for a group photograph. I thank you all for joining the session. This will continue after lunch. Session 2 is Future Trends and Challenges, and I now request all of you to please join us for the lunch. Thank you so much.